In this lesson we are going to solve some questions about the first derivative, and if you remember we were finding increasing or decreasing intervals with the first derivative. I'm going to start with d1, and fx is equal to dx cubed plus 6x, so f derivative x is going to be equal to 3x squared plus 6. This, when we have 3x squared plus 6, this is always positive. I need to explain that one to you. Here, when the first derivative is equal to 0, we were finding the table, and with respect to that table results, we were finding the function is increasing or decreasing, if you remember. And f derivative x cannot be equal to 0 in this case, because when it's equal to 0, 3x squared plus 6 is equal to 0, 3x squared is equal to minus 6, it's going to be x squared is equal to minus 2, which is not possible in real numbers, and graphs drawn in real numbers. That's why we are working always in real number set for increasing and decreasing intervals. What is the condition here? If you remember, we were doing the table, then we were drawing the plus and minus sign, plus, minus and plus signs, if there are two different roots. Here, as you see, we don't have any root. So the function is going to be between minus infinity and infinity, it's going to get only one sign. It's going to be minus or it's going to be plus. In this case, it's going to be plus. How I know that one? Because if you remember the tables here, the function, let me draw the function here. For this function, the delta is going to be delta is greater than 0, delta is less than 0, sorry, delta is less than 0, and a is greater than 0, it must be. So I know that delta is less than 0 because the result is x squared is equal to minus 2. I know that delta is less than 0, and a is positive. Here this is the a value for the, I didn't write the f derivative x function, but f derivative x is equal to ax squared plus bx plus c, it should be. So if this is greater than 0, which is 3 here, the function, it must be positive. If it is negative, the function, it should be like this, and this sign, it should be minus, and function is going to be always decreasing. So this is f derivative x, and f derivative x is always positive. If f derivative x is always positive, it means that fx is always increasing. Okay, the second one, the f1, or pardon, e1, I said e1, let's solve. E is equal to firstly f derivative x I have to find. F derivative x is equal to 3x x squared over 3 minus 4x plus 0, it's going to be. So this 3 and this 3, if we simplify, the answer is going to be f derivative x is going to be equal to x squared minus 4x. Then x squared minus 4x, which means f derivative is equal to 0. We are going to find local maximum and minimum points. X times x minus 4, we don't have a c term here, that's why we are going to get x common parenthesis, then it's equal to 0, x1 is equal to 0, x2 is equal to 4, it's going to be. These are the local extremas now. And here we are going to find this is going to be 0 and this is going to be 4. This is plus infinity, this is plus infinity, this is minus infinity, it's going to be. As you see, if there are roots, we are replacing the plane. But if there is no root, it means that you are going to choose only one plus sign and one minus sign. Here the sign is going to be plus because the x squared sign is plus, then minus, and then plus. This is the analysis of f derivative x. If we analyze the f derivative x, we will find the increasing decreasing interval of fx. Fx is going to be increasing, then decreasing, and increasing in the interval. So for the interval minus infinity and 0, the function is going to be increasing, and for the infinity 0 to 4, it's decreasing. 4 to infinity, increasing again, is going to be. Okay, the last one, the g1, increasing or decreasing, we are going to understand with respect to 2 minus x. Now fx is equal to fx is equal to f derivative x. The derivative of the function f over g, it's going to be f over g derivative. I am going to find this is f derivative times g minus f times g derivative over g squared, it's going to be, which is equal to for the last case, here this is going to be this with different color. This is the g1, and f derivative x is equal to 1 derivative times 2 minus x minus 1 times 2 minus x derivative over 2 minus x squared, it's going to be. So f derivative x is going to be equal to, here this one derivative is equal to 0, so completely this value it goes and it's going to be 0, and the derivative of 1 minus 2x, it's going to be equal to minus 1. 2 minus x derivative is equal to minus 1 because 2 derivative is 0, then minus 1 is going to be plus 1 over 2 minus x, it's going to be square, and the f derivative x is equal to 1 over 2 minus x squared. So as I understand from this value, 2 minus x always increasing, it's going to be except the value 2, because at 2 it's not defined, but this expression is always positive. We know that this is always positive. F derivative x always positive. Why it's always positive? Because 2 minus x except 2, that's undefined point, except 2, this function cannot get negative value because of this 2 minus x squared expression. And f derivative x, if always positive, it means that fx is always increasing. For what values of m the function is decreasing function? And here the m function it is given. Probably the derivative of the function f derivative x, it's going to be quadratic function like ax squared plus bx plus c. And for the quadratic function, always decreasing, f derivative x always negative. If we want a must be less than 0 and delta must be less than 0 also. So for which values of m the function is always decreasing, if we are finding this one, first I need to get the derivative. F derivative x is equal to, here it is minus 1 over 3 times 3x squared, it's going to be plus mx squared minus 4x, 2mx minus 4, and if it's simplified 3, f derivative x is equal to minus x squared plus 2mx minus 4, it's going to be. And as you see here, the first condition satisfied. If the function is decreasing, it means that a must be less than 0, and this value, as you see here, the a value is equal to minus 1, and it's always less than 0. And the second condition, delta also must be less than 0, which is equal to b squared minus 4ac, and here in this question, b squared minus 4ac, 2m squared minus 4 times 1 times minus 1 times, sorry, a is equal to minus 1 times minus 4, which is equal to 4m squared plus 16. And here we have another problem, because 4m squared plus 16 always positive, because 4m squared is positive number, 16 is positive number, it means that 4m squared plus 16 always greater than 0, so no such m function is decreasing. So this function is cannot decrease because there is no such m. So it will be maybe sometimes increasing, sometimes decreasing, but it will never be always decreasing. Okay, we are continuing with the question here, 16. And the graph of the ax squared plus bx has extremum point, which means f derivative x also, pardon, f derivative 1 is equal to 0. And the second one, what is given here to us, f1, and this is f1, it's going to be, so f1 is equal to minus 2. With respect to these two given information, we are going to find the a and b values. First of all, let's find the f1. If it's equal to 2, it means that f1, if it's equal to minus 2, it means that ax squared, fx is equal to ax squared plus bx, f1 is equal to a times 1 squared plus b times 1, which is equal to minus 2. A plus b is equal to minus 2. It's going to be f derivative x is equal to 0, so f derivative x is equal to 2x plus b. It's going to be 2ax plus b, it must be. And f derivative 1 is equal to 0 means 2a times 1 plus b is going to be equal to 0. 2a plus b is equal to 0. It's going to be, if we write these two equations, a plus b is equal to a plus b is equal to minus 2, and 2a plus b is equal to 0. And if I multiply the first one by, this is the system solution, and system solution, I'm going to multiply the first one by minus 1, then it's going to be equal to minus a minus b is equal to 2, and 2a plus b is equal to 0. And side by side, if we add them, we will find the result like this: a is equal to 2. And if a is equal to 2, a plus b, if you remember, it's equal to minus 2. 2 plus b is equal to minus 2. And 2b is equal to, b is going to be equal to minus 4 in this case.